Hello student, in this video we will see exercise 1.2. Here first question. Question number 1, prove that root 5 is irrational number. This is very simple but little theoretical part. Some steps we have to write. Let us consider now this root 5 we have to take the rational number. We have to prove it is irrational. But now assume that root 5 is rational number. So that see a and b here a and b is the sum numbers. If you are written in the form of a upon b, then it's become rational number. Here we consider rational number, so root 5 equal to a upon b. So here also I have written a upon b is a rational number because it is written in p upon q form, and root 5 we consider as a rational number. See here, cross multiplication we are taking like this. Arrow I am showing means it is a cross multiplication, means root 5 into b equal to a. Then here equation number 1, then squaring both sides. If you squaring both sides means root 5 is become a 5 and b is a b square equal to a square. So b square equal to a square upon 5. So this is the second. So here now 5 is a prime number, but here 5 divides a also. Here 5 is there and this 5 divides a also. Here 5 divides a also, means 5 is dividing a square, but it can be divided a also. So here see in here note that see let p be a prime number and let p divide a square, then p divides a also. Here also already I explained a square upon means this 5 is dividing a square means it's dividing a also. Here where a is a positive integer. Now see here a equal to 5c for a some integer of c. Here c is also integer, so a equal to 5c. Okay, see a equal to 5c, this putting this value of a in equation 2. Which is the equation 2? Here equation 2 is the a square upon 5. So a equal to 5c. Here a equal to 5c, so let's see here equation is 5b square and a square means what here 25c square. Okay, 25c square means b square as it is. This 25 is divided by this 5, so it's become 5c here, 5c square. Okay, means that this 5 divides b square and also 5 divides b also. Okay, so where a and b have the common factor here, but a and b have no common factor except 1, means our consideration is wrong. Okay, because see a and b have no common factor except 1. Our consideration is a upon b or 5 equal to a upon b. Then here only one factor is there, then it is wrong. So root 5 is a rational number, hence root 5 is a, our consideration is now, that is our, what is our consideration? Root 5 is a rational number, because after solving this again we can conclude that root 5 is irrational number. Now same way we have to solve this problem also. See now question number 2, prove that 3 plus 2 root 2 is irrational. Now let us consider that 3 plus 2 root 5 is rational. Here then a and b are integers. We can write in the form of a upon b. So therefore 3 plus 2 root 5 equal to a upon b. Again cross multiplication. Cross multiplication means what? Here this cross multiplication. So 3 plus 2 root 5 into b equal to a. Then 3 plus 2 by this b will come here, then it's become a upon b, means this here multiplication is there, then it's become division. Then this 2 root 5 equal to a upon b, then this 3 will come here, 3 upon 1. So after solving this, then you are taking the LCM of this b and 1. So here a minus this, here a will come, here it will become 3b. So a minus 3b here. Here this step c, b and 1, we have to take the LCM of these two numbers. So it's become b. So here a as it is, b is the LCM. Here already b is there, upon b is there, so a is there, minus 3 into b will come, so it's become minus 3b here, so 3 minus 3b upon a, and root 5 equal to a minus 3b upon 2b. Then root 5 equal to, so we can separate the numerator and here, so a upon 2b minus 3b upon 2b. So this b get cancelled here, so a upon 2b minus 3 upon 2. So we'll write like this, same we are writing like this, a upon 2b minus 3 upon 2 equal to root 5. But see here, a upon 2b is also rational number, and this 3 upon 2 is also rational number. Then their subtraction, this here a minus upon 2b minus 3 upon 2 is also rational number, but this 5 is irrational number. So this 3 plus 2 root 5 is also become a rational number. Then question number 3. Prove that the following are irrationals. Here 1 upon root 2. Here 1 upon root 2. Then same way we can explain here, or we can write here. Let us consider that root 1 upon root 2 is rational. A and b are integers. 1 upon root 2 equal to a upon b. Then cross multiplication here, or here this steps is given taking the reciprocal of this. 1 upon root 2 equal to a upon b. So 2 equal to b upon h is here. This steps is the taking the reciprocal of this. So b upon is a rational number, and so root 2 is rational number. But fact is that 2 is rational number. See, 2 is rational number means this here, this side is a here we consider it is a rational number, but actual this is the b upon is a rational number, but root 2 is a irrational, so this become is also irrational. So we conclude that 1 upon root 2 is irrational. Then second question here, see 7 root 5. Let us consider that 7 root 5 is irrational. A and b are integers. 7 root 5 equal to a upon b. Root 5 equal to a upon b as it is, and this 7 become reciprocal of this, or it's become 1 upon 7. So root 5 equal to a upon 7b. The a upon b is a rational number and root 5 is rational number, but this here rational number we assume that rational number, but actually it is a irrational number, no? So this side a upon 7b is become also irrational. So we conclude that root 5 is irrational number. Then see here third question, 6 plus root 2. Let us consider that 6 plus root 2 is a rational number. So we can find co-prime integers a and b such that 6 plus root 2 equal to a upon b, root 2 equal to this a upon b as it is, and this 6 this side it is coming, so it get transferred, so minus 6 it's become. A and b are integers, we get a upon b is rational, and a upon b minus 6 is rational, and so root 2 is also rational. But in fact that 2 is irrational numbers, so we conclude that 6 plus root 2 is also rational number. Okay student.